Greetings, math friends. I want to take a look at this integral here. We have 3x minus 5 squared over x cubed, and we're going to integrate from 1 to 3. In a problem like this, you might think the approach you want to take is a u-substitution, and that may be what you want to do. But then, as a u-substitution, you have to decide what to establish as u and work through that issue. Some of you might notice that we have x cubed here and we have 3x here. So you're thinking, well, perhaps you want u to be x cubed. So then du is going to be 3x squared dx. We have the 3x in here and we have the square here. And some students have the mistake of they try to distribute this square into here and they'll call this maybe 3x squared or 9x squared and this 25, and they miss the entire center term that we have here because we actually generate 3 terms here once everything is simplified if you do the square process properly. So that there's a couple avenues for mistakes in here. Perhaps we want to declare that the interior of this parenthesis is our u. Then our du would be 3. Derivative of 3x is 3. Derivative of 5 is 0. So we have 3 dx in that case. We do have a 3 up here. But even if we expand this, that 3 is going to be attached out there and not going to be able to be factored out to be a part of the product with dx. So again, this doesn't really lead us to the best place we want to be. And I know there's a lot of focus on u-substitutions. For some of you that know integration by parts, there's another approach that way. But I would like to say that perhaps you already have the knowledge that you need in just your Algebra 2 or pre-calculus skill set to be able to handle this problem without substituting anything at all. And I'd like to explore that avenue. Let's focus on the numerator here. I pulled that off to the side. Because this is squared, it's really saying that this is 3x minus 5 times 3x minus 5. We need to do a double distribution for this. We are going to first focus on the 3x. We're going to distribute that across the second parentheses, and then we are going to focus on the negative 5, and we're going to distribute that across the parentheses. So focusing on 3x first, we have 3x times 3x. That's going to be 9x squared. 3x times negative 5, that's going to be 15x. Then we are going to focus on the negative 5. We're going to take that negative with the 5 as a negative number. So negative 5 times 3x is again negative 15x, and then negative 5 times negative 5 is a positive 25. Bringing together the like terms in the middle, we end up with 9x squared minus 30x plus 25. All right, and that's really the numerator of the original integral that we have here. So we're going to substitute that in there. And then also I want to move the x cubed in line so that we have a line as our expression. So this will be distributed over this eventually. And to move this up in line, we are going to switch the exponent to a negative 3. Okay, now that we have this rewritten, we've substituted this in for here and then brought this up. We have this. Now we're going to use the distributive property again to distribute x to the negative 3 across each of these 3 terms. And we need to remember the exponent property here, that when we have a base with an exponent times the same base with a separate exponent. To combine those, we are adding these two exponents. So in this case, I'm going to add -3 to the +2. That's going to give us 9 to the x, 9 times x to the -1. Then we're going to have 30. The exponent here is 1. You didn't see it. It's like a ninja. It's hidden, and it's going to get you if you're not paying attention. This is really an exponent of 1 there. So we have -3 plus 1. This will be x to the -2. And then over here, the entire x is missing. There's really an x to the 0 power there. As long as x is not 0, any real number to the 0 power is 1. So that's what we've got going on there. 1 times 25 was just the 25. So we have x, -3 plus 0. This is going to be 25x to the -3. And we've got this nice decreasing exponent situation going on there, which is kind of the standard form when we talk about polynomials, although this isn't quite the polynomial. And then dx here, and we have our integral here from 1 to 3. Okay? So now that we have this, it's essentially a polynomial form. We are just going to go through that antiderivative piece by piece and make this antiderivative work. So this is really 9 over x. So that's kind of our classic logarithm form. We're going to have 9 log of absolute x there. Then looking over here, if we add 1 to this, we're looking at x to the -1. We want -1 times something to give us -30. Well, that would just be +30. Remember, as we take the derivative of this, we want to get this. So -1 times 30 will be -30, and then subtracting 1 from that, we get the -2. Then lastly, we are looking at x to the -2. We'll add 1 to that. Okay, so we want -2 times some number will give us 25. So this coefficient here has to be -25 on 2 here. So 2 times this will give us the -25, and then the negative times negative is the +25. All right, so this is what we have, and we are evaluating that from 1 to 3. All right, so then we just take turns plugging the 3 into this, and then we want the negative version of all of this with 1. So let's go ahead and work that out. So over here we have 9 log 3 plus 30. I'm going to write this as 1/3 here. This is x to the -1. We're plugging 3 into here, and then we would want the reciprocal of that. That's what the -1 indicates. So we're going to write this as 1/3 here. And then we have 3 is here. It's going to be squared, and it's a reciprocal, so we have 1/9 there. And then subtracting from that, we're going to start plugging 1 into here. So we want the log of 1 there. And then this is just going to be 30. So we have 1 over 1 is 1, and 1 times 30 is 30. So this doesn't change the magnitude of anything here. And then we're going to have 1 squared, which is just 1, and we want the reciprocal of that. So again, it's just 1 there. So it's not going to change the magnitude of that. So now that we have this, we want to distribute this negative here and then bring together like terms. right, so there's the first set of simplifications. We have this 9 log 3 and the subtracting the 9 log 1 here. According to the properties of logarithms, we can take this input and this input and divide them. That's the negative here. The 9 is a scalar that would have been factored out, so it's going to be 9 times the log of 3 divided by 1, which is just 9 log 3. And then these 4 numbers here, we are just going to get the sum of. This leaves us with our final answer. The integration of 3x minus 5 squared divided by x cubed from 1 to 3 is going to be 9 log 3 minus 80 over 9. So this was an interesting problem. It kind of looks like a u-substitution might be the way to go, but then that's not as straightforward as we want. But then we may realize that we can just use a skill set from an earlier time, like Algebra 2 or pre-calculus, and just rearrange this so that it's more user-friendly, essentially, and then arrive at our integration in that direction. Hopefully this has been helpful to give you some hints on problem solving. I hope you find some mathematics that interest you in your part of the world. Cheerful calculations.